Hello, geometry students. Here's your lesson for section 2-6, Geometric Proof, with Missy McCarthy, math instructor at Okemos High School. In this lesson, by the end, you should be able to say that I can provide appropriate definitions, properties, postulates, and theorems as justifications for statements in a geometric proof, compose a two-column proof if provided with a plan for the proof, recall and apply the linear pair theorem, recall and apply the right angle congruence theorem, recall and apply the congruent complements and the congruent supplements theorems. Later, you'll need to be able to do a proof without assistance. We'll talk more about this in class. All right, so what is a geometric proof? Well, all you do for a geometric proof is you start with a hypothesis or a statement that you are being given. If this. So let's say if two angles are right angles, and then you use definitions, postulates, properties, and theorems to prove a conclusion that those two angles must be congruent. Okay? And the process for doing this portion looks a lot like the activity that we did in class, where we started with one thing and we were trying to prove another. So we started with our hypothesis, which is what you are given, and you work your way all the way down to what you're trying to prove, which is your conclusion. All right, the process for completing a geometric proof would be first to write out the conjecture to be proven. Most of the time, number one is actually given to you already. Number two is actually given to you already with a diagram, and there are certain things in the diagram that you can use as well. Then you can state any given information or mark it on the diagram. Then state your conclusion, which is usually given to you, and then come up with a plan or an argument to get from what you start with to what you end with. So that's the process for a proof. Okay, so when you have a diagram, there's certain information that you can assume and certain information that you cannot assume. So look at this list here. Here are a list of things that you can assume just by looking at the picture. You can assume that points are collinear. You can assume that a point is between two other points. You can assume that points are coplanar, that you have straight angles or straight lines if it looks like it. You can assume that angles are adjacent if it looks like it, that they are a linear pair, or that they are vertical angles. So just by looking at a diagram, it is safe to assume all these things. Things that people try to assume but that they cannot assume is the measures of segments, the measures of angles, the congruent segments and congruent angles. You cannot look at a diagram and say that angle A is congruent to angle B because it looks like it is. That's not okay. And you cannot assume that angles are right angles. The only time you can do that is if it has the right angle mark in the corner. Okay, so if a diagram includes labeled information such as angle measures or right angles, then you can treat that information as given. You can put it in this safe to assume column. Okay, so looking at this diagram, based on what we just talked about, what is it safe to assume? We're just going to come up with a couple things that it is safe to assume and a couple things that it's not. One thing I'm looking at right away, it is not safe to assume that angle DBC is acute. It looks like it is, but that's not one of the things that we can assume. It's also not safe to assume that angle DBA is obtuse based on the diagram. I know it looks like it, but that's not safe to assume. It's also not safe to assume that B is the midpoint of segment AC. Okay, that's not safe to assume. There are no markings there that tell us that. Things that are safe to assume is that angle DBA and angle DBC form a linear pair. It said linear pairs are safe to assume. Okay, it's also safe to assume that, let's see, angle ABC is a straight angle. or that ray BC and ray BA are opposite rays because they form a straight line. That's safe to assume. Okay, so there's things that are safe to assume and not safe to assume based on the diagram. All right, so I said you can use properties, definitions, postulates, and something called a theorem in order to prove a geometric proof. So a theorem is nothing more than a statement that can be proven. You can start with the hypothesis of the theorem. You can use a series of logical thinking as well as properties, postulates, and definitions and other theorems in order to reach the ending part of a theorem. So a postulate was something that could not be proven. A theorem is something that can be proven. Okay, here are some important theorems that you need to know. We're not going to prove them in the video, but we definitely are going to talk about how you would prove them in class. The first one is the linear pair theorem, which says if two angles form a linear pair, then they are supplementary. The second one says if two angles are supplementary to the same angle or two congruent angles, then those two angles are congruent. So for example, if angle 1 and angle 2 are supplementary and angle 2 and angle 3 are supplementary, then it's safe to assume that angle 1 is congruent to angle 3. That's the second one. The third one is the right angle congruence theorem, which says all right angles are congruent. If we were to write it as a conditional statement, it would read, if angles A and B are right angles, then angles A and B are congruent, or angle A is congruent to angle B. And the last one is the congruent complements theorem. It actually goes along with the congruent supplements theorem. Those two say very similar things. And it says if two angles are complementary to the same angle or two congruent angles, then the two angles are congruent. So it would read, if angle 1 and angle 2 are complementary and angle 2 and angle 3 are complementary, then it's safe to say that angle 1 is congruent to angle 3. So those are the four important theorems for this section. There actually is one additional theorem, and please, please, please remind me to talk about the vertical angles theorem in class. It's very important, so please remind me to talk about that when we start class. Okay, so that's it. Again, the proofs that you do in class, you should be able to provide appropriate definitions, postulates, properties, and theorems as justification. Compose a proof. If I give you a plan, recall and apply the 4 theorems that we talked about, and I should add the vertical angles theorem there. And then we'll talk about what a proof will look like and what you will be able to do with the proof in the future, what you should be able to do now, and what you will be able to do in the future. I will see you in class.